Hi, Assalamualaikum warahmatullahi wabarakatuh and good day. So for today, I would like to share with you about the introductions of the moment distribution method. So moment distribution methods usually we apply when we want to analyze the indeterminate structure, beam as well as frame. Okay, for the contents of this slide, basically I will share with you the concepts of MDM, what is the terms required in analyzing using MDM, and then the fundamental proposition, and as well the process taken in applications the moment distribution method. Okay, basically MDM, which is moment distribution method, we use to analyze the indeterminate structures, which is beam and frame. We also have two types of frame, which is side sway with and also without side sway. The outcomes of the MDM, we will draw the shear force diagram and as well the bending moment diagram. Okay, so that's why we need to use the method of MDM. For the introduction, basically, this method is developed by Professor Hardy Cross. Okay, this is the history of this method. And the other names of the MDM is sometimes they name as relaxation method. Okay, because it's very successful, okay, when it converges to the true solution through the successive approximation. Okay, basically we have another method in analyzing the indeterminate structures, which is slope deflection equation. But MDM compared to the slope deflection equation, the advantage is easily remembered and is very useful to check the computer output, which is using the manual calculation compared to the software. Okay, this one is the what we call that the concept of MDM. The terms that required when we want to solving the indeterminate structures using MDM. The first things we need to find fixed end moment. Sometimes they also name as FEM. Some books they also known as MF, which is referring also to fixed end moment. And then distribution factors, DF. Okay, and the third is relative stiffness as well the total K, and also the carryover. So fixed moment is the loads acting on this fixed beam. It will produce fixed end moment at the ends. So basically FEM we have the table, okay, which is named as table FEM. Okay, so basically we assume positive for clockwise and negative if for the anti-clockwise direction. Second, we also have terms of K, which is relative stiffness. Okay, relative stiffness is what we call that the force required to produce the unit's displacement. Okay, so to find K, the formula of K is K4EI over L and K3EI over L. So this one will be depends on the types of supports. One of it is far and fixed, okay, which is this one. And then far and pin, which is referring to this. Okay, so that's why we will have two formula of K depends on your and supports. Okay, then when we have the stiffness, we also must have the total stiffness factor. Okay, so basically total K will be related to the K. Okay, if you look at here, if the frame is like this, so you want to find the total stiffness factor for joint B here. So we will have 3K, okay, because they will involve BA, involve BC, and as well BD. So that's why we will have 3K here. So the total K will be all these K, the summations. Okay, and then we also have DF. DF is a short form for distributions factor. Okay, distribution factor basically is about the ratio, okay, according to which an externally applied unbalanced moment at the joint. Okay, this is the example for the frame. So the dotted lines here is the dotted line here, meaning that how the frame is deflect. Okay, so this is the total distribution factor we need to find for B, which is involved BA, BD, and BC. For to continue this one, what I said previously, they will involve 3M because of the members will involve 3 members, A, B, BC, and BD. So that's why the MBA, MBC, and BD, they will involve distribution factor of K divided by total K. And then we also have carryover. So carryover, we know that MDM, we listed all the value in the table. So from one row to another row is named as the iteration. Okay, so to iterate from one row to another row, we need to carry over. Okay, this one. So sometimes we need to carry over, which is divide by half. Okay, but sometimes there are no carry over. That one will be depends on the types of end supports. Okay, sometimes the questions, they will have support settlement. Support settlements meaning that in the real conditions, the loading, okay, can be cause sinking of the supports or sometimes rotation. Okay, mostly is due to the soil settlement. So in the equations of FEM, we will have extra support settlement, which is this one, 3 EI delta L power of 2, and another one for 6 EI. So this one, the difference is the types of end supports, okay, which is both end are fixed and sometimes the other ends are fixed, but the another one is not fixed support. Okay, this one is the process involved when we want to apply the moment distribution method in solving the indeterminate structures. Okay, so this is 1, 2, 3, 4, 5, 6 that you need to apply when you want to analyze the indeterminate structures using moment distribution method. Okay, so the tabulated form, the form of MDM will be look like this. So this one will be depends how many members we have. Okay, and then this one we will have distribution factors. We will look at after this how we can calculate DF. Okay, normally distribution factor related to the degree of freedom. Okay, degree of freedom. And continue with value of FEM. FEM will be referring to the table. Okay, we have the table of FEM, and then we carry over from one row to another row. Okay, so when we need to stop if the joint connection between the end supports will be 0 or near to 0 like this. Okay, so for the next slide, we will go through into this, how we can calculate MDM to solve the beam indeterminate structure. See you next slide.